Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over slope of a line. The slope of a line measures its steepness, how quickly it rises or falls, and its orientation, whether it's rising to the right or falling to the right, or maybe staying constant to the right. The slope is a ratio of rise to run, and we usually use the letter m for slope. So rise over run is one way that we know slope. It's also equal to the change in y over the change in x. The change in y, we write that way. That triangle is the Greek letter delta. We use delta for change. So delta y over delta x. And again, that's just the change in y over the change in x. Now, if you've got 2 points, x1, y1, and x2, y2, the formula for the slope is given as m equals y2 minus y1 over x2 minus x1. And by the way, these points can be labeled the opposite way. So it doesn't matter which direction you subtract in, as long as you do it the same way in both the numerator and denominator. Where this formula is coming from is, let's say you've got some point x1, y1, and some other point x2, y2. And we're looking at the line that goes through those 2 points. If we draw a right triangle, like that, the change in the y is how it changes going up from a height of y1 to a height of y2. That's our y2 minus y1. And same way for x, along the base of this triangle, that's x2 minus x1. So it's the ratio of the change in y to change in x. Well, let's use this formula in a couple of examples here. In part A, I'm giving you 2 points, 2, 7, and 6, 13. So I'm going to label those as x1, y1, and x2, y2. Always a good idea to write down the formula as you're starting to learn how to use it. So m equals y2 minus y1 over x2 minus x1. And yeah, that took me a little time to label those and to write down the formula. But if I'm consistent with that, I'm not going to make a mistake when I substitute into the formula. M equals y2 is 13 minus y1 is 7. And that's going to go over x2, the second x, that's 6, minus x1, which is 2. And we have 13 minus 7 is 6, over 6 minus 2 is 4. And we should always reduce that to lowest terms. That's going to be 3/2. That tells us that the graph moves up 3 units as it moves 2 to the right. The numerator is going to tell you whether it's up or down as it moves to the right. The denominator always tells you how far to the right it goes. One thing for some students that are visual learners, getting in a pattern of figuring out your slope this way might be good for you. I'm going to subtract the y's on the top, 13 minus 7, and on the bottom, I'll subtract the x's, 6 minus 2. That gets me that fraction, and then I can go from there. For the second one, the points are -5, -4, and 1, -14. We've got to be careful when working with negative values. So let me label them first. x1, y1, x2, y2. I'm going to write the formula down again. y2 minus y1 over x2 minus x1. And when I go to substitute in, I'm going to start by placing the minus signs where they belong. The second y value was -14. I put that in the numerator before the subtraction sign. Trust me, it's on its way. There it goes. And then y1 was -4, so I'm going to put that in parentheses. So now I'm subtracting -4. This is really the same as -14 plus 4. When we subtract a negative number, it's the same as adding its opposite, adding the positive value of it. In the denominator, x2 was 1 minus -5. Same idea, this is going to be the same as 1 plus 5. So negative 14 plus 4, that's negative 10. 1 plus 5 in the denominator is 6. And when we reduce that, we've got negative 5/3. It doesn't really matter where that negative is, right? We can write it in the numerator like I've done it. I can write it in front of the fraction as well. They both have the same interpretation. The negative, along with the 5, tells us that the graph moves down 5 for every 3 that it moves to the right. And we'll use that idea when we graph lines using slope. A couple of quick detours here in terms of horizontal and vertical lines. Those are not correct. A horizontal line is of the form y equals 4. That typo will be fixed on the handout that you're working with. And a vertical line is of the form x equals some number like x equals negative 3. So a horizontal line means all the y values are the same. 1, 2, 3, 4. Every point on there has a y value of 4. And so when we go to figure out the slope, the change in y is 0. So if we think of slope as change in y over change in x, I know it's going to be 0 over some number, some non-zero number if I'm picking two different points for x. And 0 divided by a non-zero number is 0. So horizontal lines have a slope of 0. For the vertical line, and maybe I'll do it with 2 points this time, a vertical line, x equals negative 3, I put a point at negative 3 on the x-axis, and then it goes straight up and down from there. And maybe I'll add one more point there. This is negative 3, 1, and the intercept was negative 3, 0. So those are my, let's go this way, x1, y1, x2, y2. And so when I substitute into the formula for slope, I'm going to have 0 minus 1 over negative 3 minus negative 3. And that's the same as negative 3 plus 3. And so I end up with negative 1 over 0. That is undefined. So vertical lines, we say that their slope is undefined. You want to be careful also about using the phrase no slope. A lot of times we hear people say there's no slope, and it's a little vague because we're not sure if no slope means that the slope is 0 or if the slope is undefined. So try not to use that phrase. If it's horizontal, slope is 0. If it's vertical, the slope is undefined. Now we'll get to a non-vertical, non-horizontal line, and we're going to try to graph this using the slope. We're given the equation in its general form, 2x plus 5y equals 15, and the goal is to go from the general form to the slope-intercept form. I can then plot the y-intercept just by reading it from the equation, and then I can use the slope to count to a second point on the line, and then I just draw the graph that goes through there. So if I've got 2x plus 5y equals 15, the first thing we can do is subtract the 2x to the other side. And I'm going to write the negative 2x in front of the 15 because that coincides with the form y equals mx plus b. I'm going to divide through on both sides by 5, and I'm going to divide both terms on the right side by that 5. When I simplify, I have y equals negative 2/5 x plus 3. This 3 is the coordinate, the y-coordinate of the y-intercept. So that's going to be at 3 on the y-axis. Negative 2/5 is the slope. The negative 2 tells us to move down 2. The 5 tells us to move 5 to the right. So down 2, 1, 2, 5 to the right would be here. and then we just draw the line that goes through those 2 points. A common mistake here is thinking that the negative goes with both, and so some students will go down 2 and left 5. But if you go down 2 and left 5, now you've got a line that has positive slope up to the right, and a negative slope indicates it's supposed to go down to the right. So that's how we know that something's gone wrong there. All right, one last problem. We're going to graph the line that passes through the point 2, -4 that has a slope of 3/5. So the last line we graphed, we knew the y-intercept. That was the point we knew, and then we used the slope to count from there. But it doesn't have to be the y-intercept. It can be any point that you know is on the graph. And so if I know the point 2, -4 is on the graph, I can put that point where that is, and then the slope being positive 3/5 is up 3, right 5. So up 3 and then 5 to the right from that point gives us those 2 points. Draw the line that goes through them. All right, so we went over the slope formula and how to find the slope of a line passing through 2 points. We talked about the slope of a horizontal line being 0. We talked about the slope of a vertical line being undefined. We learned how to graph a line if we knew its slope and its y-intercept. And we finished with graphing a line if we know its slope and any point on the graph. In the next video, we'll talk about rate of change, which is related to slope.